Hello everyone, Mr. Fawcett here, and we are about to start part 2 of our literal equations lesson. Last video we talked about what literal equations were. We did an example or two, but we weren't doing those examples on our own. We looked at a student named Harry, and we kind of checked his work to see where he made a mistake. Today we're going to be manipulating these equations completely on our own. As always, before we go over a problem, I would encourage you to pause the video and try it yourself. That way you can judge how well you know the material before you see the answers and explanations. A lot of times when you don't try the problem ahead of time and you see the answers and explanations, you think, okay, that makes sense, I can do that. But you may not have been able to do that completely on your own ahead of time or even afterwards, right? It's different working through a problem while you're listening to someone explain it. The true test of how well you know the content is, can you do it completely on your own without any other resources? So again, just pause the video, give them a shot, and then come back and watch. We're going to start off with number 1. Okay. Number 1 says to solve the equation for x. So we need to get x by itself. Well, actually, let me make this a bit bigger for us. Okay. So we need to get x by itself. Couple options we have here. We can either move the x to the other side and then move the u back to the right side, or we can just move the k to the left side right away. I'm going to move the k to the other side. So I'm going to subtract k from both sides. So this is going to give me u minus k is equal to negative x. Now, we have x on one side, but it is negative. When it says solve for x, it means solve for positive x. So we have to figure out a way to simplify this negative in front of our x term. Well, this negative is really just a negative 1, which means we should be dividing by negative 1. Divide everything by negative 1. Okay, this is now going to give us negative u plus k is equal to x. Oops, that's pretty poor x, I think. Okay, so we have now solved for x. If you ended up writing it the other way, you could say k minus u is equal to x. That would also be acceptable. Of course, you could also have x on the other side, so you could say x is equal to k minus u. Okay. All right, let's move on to number 11. All right, so number 11 asks us to solve for the variable a. So we need to think about how to move the c to the other side and move the b. Let me rewrite this so it's going to be a little easier to show multiplication and division. Now, if I want to move the c to the other side, well, if I'm dividing by c, then I need to multiply both sides by c to simplify it. So the left-hand side is just going to be c times g. The right-hand side, the c simplify, and I'm just left with a b. Now I'm close to what I want, but I want to get a by itself. So how do I move the b to the other side? Well, I divide both sides by b. So I get cg all over b is equal to, the b simplifies, so I'm left with a. There's our solution. Now, of course, again, if you want to write the a on the other side and move the cg over b to the other one, that's okay as well. Let's move to 17. All right, so again, we are solving for a. Now, in this problem, a is in our denominator. So in our answer, like when we come up with our solution, we want a to be in our numerator. So A is currently our denominator. We need to think, okay, how can I get A out of the denominator? That's the first thing, okay? Well, if it's in our denominator, that means we're dividing by A. To get it out of the denominator, we would need to multiply that side by A. So again, I'm going to rewrite this just because it's easier to show the multiplication. But if I multiply both sides by A, that gets it out of my denominator. So simplifies over here. I'm left with C is equal to the quantity D plus R times A. Now you may be tempted to distribute this A to both the D and the R. But remember, our goal is to get A by itself. So our first thought should be, is there a way for me to move this D plus R quantity to the other side? Well, this quantity right here, this D plus R, is being multiplied to the A. So the inverse operation of multiplication is division, which means I can divide both sides by the quantity D plus R. This is a slightly new concept that we're looking at right now. I don't think you may have seen this before, dividing by a quantity rather than just a single number or a single variable. But what this does is it simplifies the D plus R because it's a factor in my numerator and a factor in my denominator. Thus, I'm left with C divided by the quantity D plus R is equal to A. And we have solved for A. Let me show you why you want to divide by D plus R rather than distribute. So we're still doing 17. Don't worry about 18. And let's pick up here. So let's say I get to this point. C equals the quantity D plus R divided by A. Now, if you decide to distribute, right, that is allowed mathematically. There's nothing wrong mathematically with that. And I would get D times A plus R times A. The problem is now A is, first of all, we have two A's, and we're trying to get A by itself. The second problem is now A is being multiplied to two different variables, right? A D and an R. So you may think, well, can I move this to the other side by subtracting it? Right? And you could do this. C minus DA is equal to RA. But now you have A's on different sides. And again, your goal is to get them on the same side. So that's not very helpful. So maybe we come back up here. We see that that's not going to work for us. Maybe you're like, okay, if I can get rid of this D, maybe that'll free up that A. So I'll just divide both sides by D, which means I have to divide everything by D. So I'm left with C over D equals A plus R times A divided by D. Again, this leaves you still with two A terms, and then this term has just become even more complicated. It doesn't mean, a lot of times, like when you choose an inverse operation, you can do it. It's not going to make the equation false. However, it might complicate the equation and then make it harder for you to get what you want. So the key step in this equation is realizing at this step right here, let's erase all the work we aren't going to need. It's realizing at this step right here that we need to divide by D plus R, that quantity, and then we're done, right? That is the last inverse operation we have to perform. If we do something else, it's going to become a lot more complicated. Nothing wrong with taking a misstep. Nothing wrong with doing an inverse operation that complicates your equation. It's just a learning process. So the more times you see these problems, right, when you start to see similar problems over and over again, you begin to understand, okay, I should take this approach when I see this type of problem rather than the other approach, right? Because one of these approaches seems to work for me a lot better than other ones do. And this is just trial and error, right? You don't want to just memorize, okay, I always need to do this thing in this spot, right? You want to be able to figure that out on your own because it's going to allow you to develop a deeper level of understanding. Okay, last problem we're going to get to is 24. Then this video will be over. All right, so we're solving for a again here, and I'm just going to rewrite the problem to be able to maneuver a bit better. Now, this problem can actually just be done in one step. Notice that a is being multiplied to b and k. Well, inverse operation of multiplication would be division. So if I just divide both sides by bk, that will take care of it, which would give me u divided by the product of bk. Do a little bit better with that. Is equal to a, because my bk in my numerator simplifies with my bk in my denominator. Now you could do this in two parts. It just becomes a little bit more work, but let's rewrite this again. You could divide both sides by b first to get u divided by b is equal to k times a. And then you could divide both sides by k. Now this makes the left side look a little funky. We have a fraction divided by another letter. So let me come over here, and we're not worried about 23. So I'm just going to do a quick little tangent on dividing a fraction by another number. Okay, so I just put a couple of examples up here, and now we're going to talk through them. This may be something you've talked about in a previous class, pre-algebra or a middle school math class. If you're unfamiliar with it, this is a question we can dig a little bit deeper into during another time. So not on one of these videos, but we can set up another session. Dividing a fraction by a number or a fraction. So our first example is when I'm just dividing by a number. So I'm just dividing by c, which is representative of some number. So a divided by b divided by c. If I divide by a number, that is the same thing as multiplying by the reciprocal of that number. So remember, c is really equal to c divided by 1, right? I can divide any number by 1 and it doesn't change the number. So if I want to divide by c over 1, that is the same thing as multiplying by 1 over c. So I have a divided by b all over c over 1. That's equal to a divided by b times 1 divided by c, and then I just multiply straight across. I get a divided by b times c. If I divide by a fraction, it's the same idea. If we look down here, let me get rid of that. So I'm down here now. If I divide a fraction by a fraction, I'm still going to multiply the numerator fraction by the reciprocal of the denominator. Again, reciprocal is just when you flip the fraction. So instead of dividing by c over d, I multiply by d over c. Okay, and again, I would just multiply straight across. I would get a times d divided by the product b times c. So over here, if I come back to my original problem, this gives me u over b times 1 over k is equal to a, which gives me u in my numerator, bk in my denominator is equal to a, which is the same thing we got originally. Notice how much more work that involves, though, rather than just dividing by b and k at the same time. So again, both perfectly legal in the realm of our math rules, but one is much more efficient than the other. All right, that's going to do it for this video, part 2 of literal equations. As always, I encourage you to finish the problems that we did not complete in the video. Enjoy the rest of your day, and I look forward to seeing you next time.